developing next-generation research and technology, facilitating connections between AFRL industry and academia, unlocking innovation through a culture of collaboration. This is the AFRL Regional Network Midwest.
SenseICs is a small business in Columbus, Ohio, dedicated to designing custom microelectronic solutions for defense and commercial needs. Our specializations include advanced imaging, communication, trusted microelectronics, and radiation hardening. We know there is a need for low-power, event-based image sensors that can enable neuromorphic processing capabilities in the infrared range. The ability to detect images in rapidly moving objects in the dark and in suboptimal atmospheric conditions is necessary for combat-ready ground troops, training applications, surveillance, and naval search and rescue, to name a few. SenseICs proposes to model and design an event-based infrared readout integrated circuit, also known as a ROIC, compatible with neuromorphic image processing. Our event-based ROIC addresses needs identified by the Air Force, and we believe our solution can benefit others in the Department of Defense as well as the commercial space. We are poised to advance upon the technology currently available by bringing an event-based IR imager with ultra-high image capture rates and dynamic range to the market.
ROIC. Event-based sensing is a new paradigm that enables us to track very, very fast frame rate targets, and we're looking forward to taking our patented infrared detector material, hybridizing it to the new ROIC, and bringing new capabilities to the warfighter.
Scenes on the microsecond range and high dynamic range images at reasonable data bandwidths and power consumption levels. To ease this challenge, redundancy in sparse scenes can be eliminated by capturing and transmitting only relevant scene changes, or events. An event-based imager detects changes in pixel luminance and photocurrent on a per pixel basis, so only significant events can be captured and transmitted, allowing for both efficient data processing and reduced power consumption. This requires the pixel front end to transform from a synchronous integrating charge transimpedance amplifier or direct injection-based pixel to a continuous time on-demand asynchronous pixel. The new IR asynchronous SenseICs pixel presents a challenge to the imager digital backend that is typically operated in a clock-driven or frame-based fashion.
At SenseICs, we typically develop frame-based synchronous imagers. Therefore, most of our previous digital IP is not directly reusable for this application. Under this effort, we have redesigned and implemented preliminary versions of new asynchronous primitives required for an event-based readout in 180 nanometer technology. Additionally, we modified these primitives to include design for test structures to increase end-user verification and testability. The next steps will be to include these primitives in a custom digital design flow to accelerate layout and increase flexibility, which is critical for the next generation large format IR event-based sensors.
So now that we are at the end of our first funding increment, we have modeled different event-based pixels with different sensing modalities for midwave IR imaging. We then evaluated their performance based on key performance parameters like temporal contrast and contrast threshold. We then built a new asynchronous digital readout compatible with standard digital design flow to transmit pixel data if and only if an event is detected. This is accomplished using handshaking logic that can also handle priority and data congestion in a user programmable fashion.